Hello! Today we're going to be learning about polygons. So you've already studied that a polygon is a many-sided figure. It's 2D and it doesn't do things like have lines that cross. It has to be closed. It can't be open. It can't have curves. It has to be all straight lines. Anything else? Think on it if I forgot something. All right, so here we have up here another definition that falls into polygons, and that is regular polygons and irregular polygons. So a regular polygon is a polygon where all the sides are congruent. Congruent means equal, the same. So all the sides and all the angles must have the same measurement. So if I was going to take a triangle, we'll start with three. A three-sided polygon is a triangle. And if I'm going to have a regular triangle, I would have all the sides the same measurement. Now, I just drew this freehand, so chances are very slim that these are actually the same. So this is what we do. So that we don't have to measure to know if it's the same, we can just express to one another that they are the same by marking the sides and marking the angles like this. I can say this side is equal to this side, which is equal to this side, and I mark it with a little slash mark. Now I do the same thing with the angles. I can take a writing instrument and I can write a little arc, a little curve by the angles to show that those three angles, this is the same as this, which is the same as this. Now I'll show you what it looks like when they're different over here with our irregular triangle. So triangle is 3. I need 3 sides that are different this time. At least one of the sides has to be different. 2 might be the same, but at least one has to be different. So I'll make this really long and this one really short. That one's almost as long. Now in this case, they're all 3 different measurements on the sides. So I'm going to mark this is one measurement. This is another measurement. I'll mark it with 2 lines. And to show that the third line is a whole third different measurement, I'm going to mark it with 3 lines. So we have 3 different measurements going on there. Now we do the same thing with our angles. We have, this is one angle measurement. This is a whole different measurement. So I'm going to do 2 lines. That means there's the second measurement. And then 3 lines for the third measurement. Kind of cool. Mathematicians like to have a little bit of artwork in their angles. Now let's go ahead and look at what the next polygon with 4 sides would be. That's called a quadrilateral. So let's make a 4-sided regular quadrilateral. That's called a square, because all 4 sides are equal and all angles are equal. So we'll do straight down. Oh, my paper is gridded, so I can do a good square this time. 4 across, 4 down. This, I know those are all equal. So let's mark them with our lines so that we can tell that even though we're not measuring them, we know that this is equal to this, which is equal to that, which is equal to that. They're all equal. Now, let's make an irregular quadrilateral. 4 sides, 4 angles, but they are not the same measurement. At least one has to be different. So let's go 1, 2, 3, 4. Oh, I missed the mark. Right here. 4. There we go. 1, 2, 3, 4. All right, now let's mark it differently. This one is one measurement. This one is measurement 2. This one is measurement 3. And this one is measurement 4. I mark them with different marks to show that they're different lengths. Now let's do the same thing with our angles. This is different. Number 2 is different. Number 3 is, it's really skinny. See that? And this one's really wide. It's very wide. It's obtuse. So that's yet a 4th measurement. 4 different measurements on that one. All right, let's try one more, the pentagon with 5. So we're going to make a 5-figured polygon, or 5-sided polygon. 1, 2, 3, I'm running out of space. Can you see it? Let's see, here we go. 4, I'm going to have to just fake it here. 5, and we're going to say they are the same, even though they are not, they don't look the same. But if I mark it that it is the same, regardless of what it looks, then we say, all right, it's the same. She didn't draw it very well. But this equals that, which equals that, which equals that, which equals that. So if I say this is 3 inches, they're all 3 inches. Even if I drew it a little sloppy, we know they're all supposed to be 3 inches. Okay. And the angles are all going to be the same. So this angle equals this angle, equals this angle, equals this angle, equals that angle. Even though they don't look it, those marks show that they are the same. Now let's draw an irregular one. An irregular pentagon is going to have 5 sides, 5 angles, but it's going to be, they're going to be different. It's going to kind of look like that one. All right, here we go. 1, 2, 3, 4, 5. There's my pentagon. They're different sizes of lines, different lengths. This one is different from that one, is different from that one. I think these are the same, so I'm going to mark them the same. 4. So I have 4 different measurements. But it's okay because they're not all the same. An irregular shape, at least one has to be different. And so we have also our different angles. This one is different from that one, different from that one. I think these are the same, so these are going to match 3 and 3. But these are different. And then this one right here is very different. So we have our 5 angles and our 5 sides. They're not all the same. So that's an irregular polygon. All these irregulars over here and regulars on that side. So I hope you understand what regular and irregular polygons are, and I hope you understand how to mark them with the lines and the little curves for the angles so that you can tell if the measurements are equal or if they're different. All right, happy polygoning. Bye.